Good afternoon. Today we are going to see the stress diagrams, and we are with two methods for stress diagram. First, we are going to see working stress method. So let us now we are considering this as singly reinforced beam. Why singly reinforced? So let us we have this is AST, area of steel on tension side. If you have steel on tension side, that you have to keep in mind, not on one side. If steel is on tension side, then we have singly reinforced beams. Now if we will see the strain diagram for this, then we have this strain diagram that is triangular, and then we have this is strain in concrete and this is strain in steel. So we have epsilon S strain in steel, epsilon C strain in concrete. Then we have this as, so this is strain diagram. So now if we will see in working stress method, we have strain and stress diagram are similar. So we have this as stress diagram. Now you can see this is stress in concrete. So if it is balanced section, then we can write it as sigma CBC. And then we have this is T by M. If it is balanced section, then it becomes sigma ST by M. Why we have divided by M? Because we have this as modular ratio, and this T by M, this is stress in concrete. Stress in concrete at level of steel. At level of steel. Why we are considering this by M? Because why we are considering this stress in concrete? Because when we will draw a stress diagram, this should be for similar material. We cannot draw it for different materials. So now we have this as stress diagram. Again, we have triangular, and if we will see, then we have this will be total compressive force. So this is our neutral axis. Above this we have compression, and below this we have tension. Now we have C, that is total compressive force, and that is equal to B into area of stress diagram. Now this area of stress diagram we can have B into area of stress diagram. So let we have this will be N, which is neutral axis dimension. So we have B into area half into N into C, and this will be my compressive force, which is C, that is half B and C. Now where it will act, as this is triangular, so you can see it will act at N by 3. So this is acting at N by 3. Now we have tensile force, which is T, and this tensile force we can have T into AST. And then simply these two should be same. We should have C equal to T, because this is in equilibrium, and we can find MR, which is equal to C into lever arm, that is equal to T into lever arm. So we are completing this working stress because we are not going again for working stress. So we will have simply half B N C into D minus N by 3, or we can have this as TAST into D minus N by 3. What is D minus N by 3? So D minus N by 3 is lever arm. You can see we have this as lever arm, which is D minus N by 3. These two are equal parallel forces, equal in magnitude, opposite in direction, forms a couple. Now we have this distance as D, that is effective depth up to the center of the steel. So why working stress method is preferred? Because calculations are very simple. We have this as linear diagram. So if we have doubly reinforced section, then also we can find values very easily, as we have this as linear and therefore we can find just by proportion the values of the stresses in compression strain also, and this is becomes very easy. As stress diagram we have same as the strain diagram. But if we will switch over to the limit state method, now you can have these assumptions. So first we have plane section remains plane after bending. Then this is most important. The maximum strain in concrete at the outermost compression fiber is taken as 0.0035. Then we have an acceptable stress strain curve is given in figure for design strength in concrete shall be assumed 0.67 times. This is given in assumption, and the gamma m which is given 1.5. Now you just see stress strain diagram. Now you can have this. So till 0.002 strain, your diagram will be parabola. And after that, we have this will be horizontal line till 0.0035, because we know till point we have maximum strain is 0.0035. Now FCK we have that is characteristic strength, and here it is clearly mentioned. So this shall be taken for the structure as 0.67 time characteristic strength, and therefore it is this curve will be multiply all values by 0.67, and we have this will be secant curve. Now we have to divide it by gamma m, and we have gamma m as 1.5, and this value comes 0.446 FCK. So now 0.67 FCK divided by 1.5, we have this value, and this will be maximum stress in the concrete. And now we are going to consider this stress strain diagram, and then we are going to find the other values. Now what will be my strain diagram, that you can see here. So maximum strain in concrete is 0.0035. This already we have seen over here. Now next assumption we have tensile strength of the concrete is ignored. The stresses in the reinforcement are derived from the representation stress strain curve for the type of steel used. Typical curve are given in figure 23. For design purpose, the partial safety factor, this is given as 1.15 shall be applied. Then maximum strain in tension reinforcement, that is at failure, we are going to get it as not less than, and that is given over here. That value is given, which is Fy upon 1.15 ES, which is maximum strain in tension reinforcement. Now we will go to the strain diagram, which is given in IS 456. So we have this value maximum 0.0035, and then in steel we have that is 0.0032, that is concrete plus steel, which is Fy upon 1.15 ES. This is strain in steel. So we have this will be the strain diagram. So now you can see strain diagram we have in this, that is linear. But stress diagram, if we will see in this, then we have curve first, and then we have this diagram will be straight line. And here we are going to consider the same. So here we will have this diagram, that is parabola. So now this value is exact value. If we will see, you have 0.446 FCK, but approximately it will considered as 0.45 FCK. Now we know we have this value, this rectangle, that is 0.002. This is total value XU we have. This is X. Then we have this value, which will be XU minus X. Now we are interested to determine these values. So we will calculate these values. So now stress diagram will be very clear, which is given in IS 456. Whereas in case of working stress method, both are same. So strain diagram is not required. But here we require strain diagram to calculate these values. Now you can see we have this will be total, we have XU and 0.002. So now if I will go with strain diagram, and then we have this distance as x, then how we will write it? So we can write x divided by 0.002, which is equal to xu divided by 0.0035, and then from this we will get value of x, that is equal to 0.002 into xu divided by 0.0035. Now if we will solve this, then we will get this value. So this will be 2xu divided by 3.5. So and from this we will get it as 4 by 7 xu. So we have x equal to 4 by 7 xu. So we will get this this value, which is 4 by 7 xu, which is parabola part. Now this value we have xu minus x, which is equal to xu minus 4 by 7. And now if we will solve this, then we will get this as 3 by 7 xu. So this value we will have 3 by 7 xu. So this part 3 by 7, which is your rectangular part, and parabola part we have 4 by 7. So now from where we are going to get these values, that we should know, and we have this as 3 by 7 xu, and this will be 4 by 7 xu. So likewise the difference here we have, now there we have directly calculated value B force equal to B into stress diagram. Here also we have to calculate it as B into stress diagram. So that will be compressive force. So if I will write here C equal to B into stress diagram, but you can see here stress diagram is not easy. We have combination of rectangle and parabola, and that we have to consider, and then we will get value of C. So this is CT and MR, that we will see in the next video. So today for this we will stop here only. Thank you.